Welcome back everyone, I am Shoptapurni from BioLive. Hope all of you are doing very well. So in today's video we are going to discuss about inversion of sucrose. So often you may have heard the term that sucrose is an invert sugar. So why do we call sucrose as an invert sugar? See, as we all know, sucrose is a disaccharide made up of D-glucose and D-fructose. Okay, now it is your task to comment down below what kind of glycosidic bond is present between glucose and fructose in sucrose. Okay, now generally the sucrose solution is dextrorotatory. And the specific rotation is plus 66.5 degree. Okay, now what is dextrorotatory? See, whenever the plain polarized light is passed through the sucrose solution, it rotates or converts the light towards clockwise direction. Okay, so the clockwise rotation is known as dextrorotation, and if it rotates the light into the anti-clockwise direction, then we can call it as levorotation. Okay, so sucrose solution is generally dextrorotatory of nature. Okay, now when sucrose acts with sucrase or invertase enzyme in presence of water molecule, or sucrose is boiled with hot dilute acid, it gets converted into its monosaccharides, that is D-glucose and D-fructose. Okay, now both glucose and fructose are in pyranose form, so we can also call it as D-glucopyranose and D-fructopyranose. Okay, now see that D-glucose or D-glucopyranose is a dextrorotatory sugar. Okay, and it is showing plus 52.7 degree dextrorotation, whereas D-fructose is levorotatory. Okay, and it is showing minus 92 degree specific rotation. So if we just disconsider, or if we just see the value 52.7 and 92 irrespective of what is plus sign or minus sign, which one is greater? Obviously 92 is greater than 52.7. Okay, so obviously upon hydrolysis, the equilibrium mixture of D-glucose or D-glucopyranose and D-fructopyranose will show overall levorotation. Okay, so when there is a solution of sucrose only, then the plain polarized light is rotated towards the clockwise direction, that means dextrorotation occurs. But upon hydrolysis, the same sucrose solution, when gets broken down into D-glucose and D-fructose, it converts or it rotates the plain polarized light anti-clockwise, so that means it shows levorotation. Okay, and the value of this specific rotation is minus 20 degree. So upon hydrolysis, the dextrorotatory sucrose solution gets converted into levorotatory solution, and this inversion from dextrorotation to levorotation in the optical isomer is known as inversion of sucrose. That means here the optical rotation is getting inverted upon hydrolysis. Okay, so that is why sucrose is known as invert sugar. Now one thing is to remember that invert sugar is mainly found in honey, and invert sugar or invert sucrose is more sweeter or sweeter than normal sucrose. Okay, just remember that. Now you may ask me, from where this 52.7 degree and 92 degree is coming. Okay, now I will clear that too. See, whenever sucrose is hydrolyzed, initially it gets broken down into alpha D glucopyranose and beta D fructofuranose. Okay, so glucose and fructose, D-glucose and D-fructose is formed initially, but glucose is in pyranose form and fructose is in furanose form. Pyranose and furanose are isomers of each other. Okay. On the other hand, you can also see initially the D-glucose is in alpha anomer form, whereas the D-fructose is in beta anomer form. Okay, anomers are also kind of isomers of carbohydrates. Now both of these alpha D glucopyranose and beta D fructopyranose are dextrorotatory. Okay, but after some time, the second one, that means the beta D fructofuranose, these beta D fructofuranose get converted into alpha D fructopyranose and beta D fructo so here the change is from furanose to pyranose. Okay, so now both the isomers of fructose is getting converted into pyranose form from furanose form. Okay, and these two pyranose of D-fructose both are levorotatory. See, this is showing minus 21 degree and this is showing minus 130 degree, 33 degree levorotation. And in the equilibrium mixture of these two anomers, we can see the overall levorotation becomes minus 92 degree. Okay. Now you may ask me, if I add these to minus 92 degree does not come, so how come minus 92 degree? See, the value, what will be the overall value of levorotation depends upon the frequency of these two anomers. Okay. That means frequency means the concentration. Depending upon the concentration of these two anomers, the final value comes to minus 92 degree. Okay. Similarly, in case of alpha D glucopyranose, we can see it gets partially converted to beta D glucopyranose. Okay, so both of these are pyranose, and two kind of anomers, alpha and beta, you can see here, and both of them are dextrorotatory. One is 102.2 degree and another one is plus 18.7 degree. And similarly, in the equilibrium mixture, they show 52.7 degree dextrorotation based upon their concentration in the equilibrium mixture. Okay, so now you can clearly find out from where this 52.7 degree and minus 92 degree is coming for D-fructose and D-glucose. Okay, now I think this is clear in your mind. Okay. So I hope the video will be useful for you, and if you find this video useful, don't forget to hit the like button and share it with your friends, and don't forget to subscribe to my channel for more such videos. Thanks for watching and happy learning.